Welcome to clickmyproject.com. Our product title is 3-level PWM floating H-bridge sine wave power inverter for high voltage and high efficiency applications. Next we see about abstract. Power electronic converters, especially DC to AC sinusoidal pulse width modulation inverters, have been extending their range of use in industry because of their numerous advantages. This product aims to extend the knowledge about the performance of 5-level cascade H-bridge multi-level inverter topology using space vector pulse width modulation technique for fixed DC source. The output voltage is the sum of the voltage that is generated by each bridge. The switching angles can be chosen in such a way that the total harmonic distortion is minimized. It also incorporates LC filters and hence output is drawn near the sine wave because of more levels. Result of experiment proved efficiency of 95%. This product presents a topology of a single base floating full bridge 3-level pulse width modulation power inverter suitable for high voltage high power DC to AC conversion. High power efficiency is obtained from the slow biasing of the high bridge power supply terminals allowed by a particular arrangement and control of two complementary active neutral point clamped voltage source converter that results the main PWM switching voltage as well as the maximum drain source voltage VDSS of related transistors are reduced to one half of the input VDD voltage. This product introduced the main concept of the floating H-bridge topology and presents in detail the circuit realization. The proposed symmetric inverter results in reduction of power switches, power diode and extra gate driver circuits, and also it may further minimize the installation area. Next we see about the flow diagram of our product. An existing system has some disadvantages such as it requires more number of clamping diodes and increasing the voltage level the system is difficult to control and the cost of the system is increases. The system is bulky and need more space and is costly. In our proposed work we achieve the drawbacks of existing system and compare to the result with existing method. In our proposed system having some numerous advantages such as lower harmonics, low switching losses, low stress on switches. To reduce the number of switches, the overall bulky is reduced and high efficiency. This is our proposed system block diagram. Here having 5 modules. The first one is source module. This having input source. The input source is a DC supply. This DC supply is fed to the H-bridge topology. H-bridge topology is nothing but is a module to connect the switches in a manner, and here using IGBT switches for the switching purpose, and here having 2 base legs, each base leg having 6 switches, and the one base leg is connected from the input source, another base leg is connected across the load, and this load is connected in between the 2 base legs, and each IGBT switches is pulsed from the pulse generation circuit. Here we using space vector pulse with modulation technique that pulses is generated from the pulse generation circuit. After that, using of gate driver circuit, the pulses is given to the IGBT switches. Due to the switching pulses, the output is delivered across the load. Here we using resistive load. This is the our load. In this load is connected in between the 2 base legs. Next, we see about the running process of our product. In our product, we using floating H-bridge multi-level inverter topology. Generally, we know that inverter is a process of conversion of DC to AC, and here using of floating H-bridge inverter having numerous advantages compared to the existing method, and main thing is reduce the total harmonics distortion, and the some advantages are low harmonics, less number of switches, and overall system cost is reduced, and the space is reduced. Next, see the output waveform of our product. This is the input DC source voltage. Here the this is the value of input DC supply. Here we using 450 volt DC supply. And next one, the see the output current waveform. This is our output current waveform, 0 to 2 amps maximally output waveform. And next one, the output voltage. The maximum voltage of output is 250 volt. And the next one, the output pulses waveform. And here the 6 switches pulses is zone. And next one, the other 6 switches pulses is shown in here. And next, see the total harmonics distortion of our product. In our product, the output voltage waveform is shown here. The corresponding total harmonics distortion is shown in here. The value is 13.98. So compared to the existing method, the total harmonics distortion is less, and this is the main advantage. And compared to the existing method, this is a very efficient product.